Good afternoon, ladies and gentlemen. My name is Mark Sanderson from CMA, and this afternoon we want to talk a little bit about how media design influences environmental challenges and inkjet quality and general print quality in total.
And my name is Pierre-Alain Brugger, and I am a physical chemist and a photochemist, and I've been designing inkjet media for 20 years in a manufacturing company.
And we're also very privileged to have young Sophie with us today, who's just going to join us and add comments and wisdom as we go along.
I don't know I'm turned on. Have you turned me on? Yes, I'm turned on. I don't know. Yeah, I don't know quite why I'm here, but I thought I'll just come and wreck proceedings, but I'm sure I'll add to them, really.
Okay, as with everything in life, design and ideas come from 9 times out of 10 salespeople, but what must always follow a good idea and a good design is functionality. And so what we tend to do at CMA is listen to some of our clients and come up with some creative ideas, and then hand it over to the clever people there who try and make the ideas we've got turn into reality.
So this is just to illustrate that the function can have several designs.
Okay, so this afternoon we want to run through a few things that we've been working on with some of our customers and some of the brand owners that we have, and we just want to talk to you about how design of media is not just simply putting a coating on or taking an existing product and changing it and everything works fine. There's quite a lot of engineering and thought process goes into behind some of the products that we make. Also, what I wanted to do today is just give you a little flavour of CMA, talk about some of the market challenges that we have, go into some detail as to what makes an environmentally friendly media, talk to you a little bit about Perfect Trans that we've launched today at the show with Hewlett-Packard, some of the ink-saving ideas that we have, and just generally how we look at media design and how it impacts on the environment. But firstly, I just want to explain a little bit about who CMA are. We were founded in 2006. We're predominantly a colour management company, and we look at colour and print solutions in a slightly different way. We were acquired by Ilford Imaging, who sadly went out of business a couple of years ago, and we've now come under private ownership. We're a global company, and we have partnerships with a number of different manufacturers and OEMs. We work with Xerox, we work with HP, we work with Roland, we work with MacTac, and we work across all sorts of different fields within the inkjet industry. So we're a proofing company. We also have a lot of wide format experience. We design and create layers, and we have a consulting division, and we also are into specialist packaging proofing solutions, and we also have launched our SSP program, which I presented earlier, which was how we help global brands manage color. We're a member of a number of different federations, and we go to a number of different trade shows around the world, and we have a global client base. Okay, so market challenges. There's a number of different things that hit us, and a lot of the big drive at the moment is recycling and how we can design medias that have the same performance of traditional materials but have an eco-friendly or a slightly ecological background to them. And typically the challenge is when people look at using a recyclable media or making a media that can be recycled, the coatings, or people expect that there is a lack of performance. In reality, that is completely different these days. There's a lot of drive going in with the different print techniques out there, and with clever layer design, you can basically manufacture media which outperforms some of the traditional medias that are out there, and also sometimes has a cost benefit as well. Okay, so one of our clients came to us, and it's been a challenge that we've taken on from the last 5 years. They were using the photographic process RA4, and it was a Duratran, particularly good quality. You've got a history, you've got a particularly good brand in Kodak, but this brand, who was a cosmetic brand, turned around to us and said, basically, we have a major problem in store. We can't dispose of the POS once it's in place. It has to be taken away, and we want a more eco-friendly solution, but we do not want to lose anything on quality. So a gauntlet was thrown down to us, and it's taken us quite a long time to crack it. So luckily, with the latest Gen 3 inks from Hewlett-Packard, we've developed what we've called Perfect Trans. Basically, it performs like a Duratran, it looks like a Duratran, but it has the eco solutions as well, and basically is outperforming, and we've launched it here at the show. However, what I'll do is I'll pass over to Pierre-Alain now, who basically will go into a little bit more detail as to how we had the journey with Perfect Tran.
When you consider the eco-friendliness of a media, there is plenty of factors to consider. Plastic recycling, so that's one factor when you choose of the base. I will not go in details reading of that. From polyester base or high-density polyethylene or PVC, nasty one, or polypropylene base. Okay, so there is a lot of consideration. Eco-friendly chart, also there is people considering the friendliness versus ecology. If it is a paper, recycled paper, FFC pulp that you use in a photographic base, etc., or paper including a resin component like photographic paper. Photographic waste, as Mark mentioned before, the predecessor of this product have been made by traditional photographic process. Even today there is a lot of the photographic chemistry has been cleaned a little bit with heavy metal, silver extractor, etc. But you can say in the making of a photographic paper, silver halides, the mercury, selenium, there is silver content. So the friendliness of traditional photographic paper is not as good as current inkjet things. When you make a paper, there is a lot of factors to consider from the lab. When a chemist is thinking that, you can think, yeah, I can take a better base. I will not take vinyl, but polyprop, etc., etc. For the photo base, same consideration. You can have a layer, ink absorbing layer, which is also economical in energy consumption, and then the last step is separating energy. But at the end, with my marketing in the past, I've always a discussion. Every solution you bring which improves the eco-friendliness has a cost for the customer, and now what is the customer ready to pay for this ecology? In terms of the base, a better base, or quality. Or for example, when you make a photo base, you use biopolymer instead of polyethylene. And this biopolymer, which degrades with time, with humidity, or 5 times, 10 times more expensive than polyethylene. So there is a lot of question at the end. You can make a very green product, not greenwashing, but a really green, but at the price that nobody will buy. So at CMA we have a range of recycled media. I pass that the voice to Mark again.
Thank you, Pierre-Alain. So Sophie, I just want to ask you, you have a mass and a vast experience in the industry. What is your current view on the drive towards recyclability? We met a few years ago and we were looking at the biodegradable products, and we generated biodegradable products, and basically the industry didn't accept them. We've launched this, we've had a great take-up on here. Can you give us a little bit of a flavour of where you think the market is regarding recycling?
I think the market's still a little bit doubtful about cost, and just general awareness across all industries about the value of recycling and something being recyclable. I think there's a lot of cynics out there. Even if you look at your household waste, I'm told I split my household waste into recyclable and ordinary, and they tell me it all goes in the same landfill. So you tend to get a little bit cynical and think, why should I bother? why should I be putting in my level of responsibility if it stops there and the end user isn't going to get a benefit? And I think it needs to improve, and we've had problems obviously with the compatibility of inks, the durability of the material, and I think it's taken quite a long time to develop something that isn't traditional. There's another thing I'd like to ask you on this immediately is, what about de-inking?
Well, that's very interesting, because one of the things that we've looked at and talked at with recycling companies is they are not so fixed up, especially in the polyester recycling, which is what our base product is. They just want polyester. And for the reasons you're talking about, when you take the recycling channels, that they're basically dumping it rather than splitting it, they want polyester. We talked to a couple of companies in the UK, and they said, if you can just give us polyester, just keep giving it to us. We don't care what's on it. I said, well, hang on. And they were like, no, we need base polyester. So recycling, I think the consumer wants it. The industry say they want it, but actually the recyclers are the people that really want it, because they can use it a lot more than we give credit for.
But I also think you have to look at how that recycling happens physically. We had crazy situations, and I think I won't name the manufacturer, but in fact all their recycling was having to be shipped, say from the UK to one central point in Europe, which kind of eroded all the cost benefits and a lot of the more carbon neutral benefits. So where you were gaining on the recycling and the actual fabrication and the performance of the material, you were losing it in logistics. And another aspect just on the same logistical side is that a lot of, I'm from the UK, and we're not as green as the Netherlands and various other countries like that. What tends to happen is there's some poor soul out in the pouring rain, buy a couple of skips on a Friday night. Did I scare you off? Sorry. Come back. But somebody's got to be out there deciding whether the stuff's gone in the right bin, because if it doesn't go in the right bin, you get fined. You're still here? Good.
Yeah,
Good.
you can go, don't worry.
You can go now. But I think, a lot of the practical aspects, we all want to do our green bit, but when you look at some of the practical aspects, the authorities that control what we do as businesses or even in a residential environment, and that will affect paper and any of the polymaterials, if you like, we have life made quite difficult for us. It's not as simple as you think it is. You think, recyclable, we can just pass it along to a specialist, but we can't.
It's a good point. I don't disagree with that. And one of the issues that we find is making a recyclable product. If you look at the pros and cons of it, you take one of the issues we have, you change a traditional product and you make a new product, and basically the brand then isn't as strong, so you have some issues with it, which leads nicely into why we worked with HP, because HP have done a fantastic job with latex, and the new generation is even more eco-friendly. And the reason we work with HP, not only from the environmental side of things, but their inks have a great color gamut, and basically the latex is probably the cleanest of anything that's out there on the market at the moment regarding recyclability and environmentally friendliness. And HP are putting a massive emphasis on the environment when it comes to their machinery. So when we're talking about inks, that leads me nicely into my ink saving side of things as well, because when we look at the environment and when we look at manufacturing recyclable medias or high quality medias or medias that print quicker, you also got to look at, from the ink point of view, what we can do. So within the programs that we have with SSP and with the Perfect Trans, we also have our built-in profiling tool, which is online, which means you don't have to have someone going to the site to profile. It can be downloaded, and basically a couple of reiterations, you've got a bespoke profile to your own print device. And basically built into that, we add basically, depending on what you're printing, but anywhere between 10 and 30% ink saving. And that's not image degradation, so it's not ink reduction, it's a proper ink saving module where you don't see any decrease in the actual quality of the image that's being printed. Okay, so I'm going to hand you back to Pierre-Alain now, because I've talked about coating. And there's a lot more that goes into a coating. So next time you put a piece of paper in your inkjet printer, maybe you'll see there's a little bit more science in it. And when the color doesn't look as good as the previous pack that you've used or a different pack you've used, there might be some scientific reason as to why that's different. Pierre-Alain.
Yes. Maybe you cannot imagine what complex situation is within an inkjet coating. You think it's maybe a very thin coating doing fix ink, absorb the ink, and that's it. When you design a coating, so there is a lot of pre-requirements to be given, apart from eco-friendliness or not, the look and feel, lay flat, the curling, the feeding, the friction on the base. The white point is quite important for certain application. For the proofing application, the OBA level, where you put the OBA, the reproducibility, something you need to understand for the proofing application, or maybe for the photo application or commercial below 3 or 5, it's okay. And then what is the post-print performance? Once you printed the things, you need a large color space, which is the influence between the ink and the media, not only the ink or not only the media. High ink limits, the instant dry feature, so you should handle just at the exit of the printer. Over inking is a problem, blotchiness is a problem, matting or bronzing, so the interferential gloss, you don't want to see that. And there is a lot of chemistry made without this quality feature. So I will quickly go through. I think it's interesting. I think nobody is in the paper making industry. No, okay. So just as end user. Okay. So a paper is a complex assembly, 5 to 8 layers. There is a core paper, so it's the pulp. It is sandwiched with an anti-curl layer based on polyethylene or plastic extrusion. The front is also polyethylene, which is loaded with white pigment and colorant to make the reflection, so a super white background to have a saturated image. And then you start with an absorbing layer. So the layer should glue on that. So polyethylene is difficult to glue something on it. Additional layer, absorbing sponge to take the ink vehicle, color fixing layer. Here I give the example of pigments, they stay on the surface, but for dyes, which is not popular anymore, but for some application, the dyes are going in the layer and be fixed here and give the gamut. And the protective layer has a lot of property because that's the first interface that the drop is hitting when you print an inkjet paper. Basically, the ink receiving layer is about 1/4 of an air diameter. My hair, let's see, which are about 80. Not
Mark's hair.
Not his hair. Not his hair.
Not Mark's hair.
And in this 1/4 of air diameter, there is a lot of things happening. The base, I just mentioned the base, why you need some base for cockling free, visual aspect, if you want a pearl, a photo pearl, or the polyethylene base, the photographic base, if you want the satin semi-matte or matting in the layer, or the control of several properties. Okay. The white point is also important, so you control in several places where you put your correction for the A star and B star, and to adjust M0, M1 measurements. The printing performance, no, it's what material scientists and physical chemists put in all this layer, and all this layer there is a lot of chemistry and nanotechnology. We talked before over-inking, ink uptake, absorption speeds, etc. The top layer, I mentioned that's the first to contact the drop, so it's a very specific feature. And now I can show what what are the influence of the different parameter here. Looking inside the layer, so you use nanotechnology. Before we talk about air diameter, so 1/4 on this, on 1/4 of air. But if you look in the particles, in the nanoparticles forming the layer, they are now in the range of 10 nanometer, and 10 nanometer is now 10,000 times thinner than air. And the particles are so small that even do not interact with the light. So that's solid particle, but they are totally transparent. And there is a molecular modification on the surface to take the ink and to take the dyes on the surface. There is so needle-like nanoparticles or round-shape-like nanoparticles, and with that you form a kind of solid sponge. And this layer is basically most of the nanoporous and microporous technology, modern technology. Now it's empty, you buy air, you buy 80% of air and 20% of skelecton of this nanotechnology skelecton. Why it is important? Because I said that you can have very transparent particle, so that means for the photographer you can have a curve which is like that, so that you cannot print more than maybe 2.1 in density. But if you have more transparent layer, a better chemistry, you can even go up to 2.5 with the same ink, the same profile, the same everything. So it's really material science which bring you higher density range, so you have more exposure and higher density with your things. Also, what happens inside with the ozone, with the dyes can be photo bleached and have a loss of stability, so you can make a lot of things. That's an example. If you expose this value of ozone, that's about 1 year of outside temperature, so you have a bleach of different color, and you see so the gray balance is changing. Different problem with the coalescence, it means if ink are not absorbing too fast or feathering, etc. Also influence and sharpness of the dots, and addition of the pigments can be influenced from the top layer. And you see after 1 minute you print on an Epson printer, you print and you smudge, and on poor material, okay, the layer is going out. On good material, after 1 minute, the dye, the pigment is already fixed and having a good adhesion on this structure, which is this top layer. So very nice chemistry. Also optical things, don't want to go in details, but probably if you have printed with a pigment printer on a glossy media, you see the unprinted area are glossy. And when you start to print with some color are becoming matte and some color are staying glossy. And that's, to get the photographic aspect, is very annoying. That means the blue-green, especially you get a matting, and the yellow, for example, you get a big gloss. So the difference is visually very, very annoying. And working on the chemistry, you can really improve all that to different media. Stability, there is some domain it is very important. Here it's artificial aging. If you treat with light several material 1, 2, 3, you treat with light, with humidity, with temperature, and here you measure the change in the white points, the yellowing, the delta E, and you can see there is some material which doesn't change 0.02 in delta E. There is material which change 6 times more yellowing, more instability of the white point. This is very important for the proofing material. When you design a proofing material, the white points, because it's a contract proofing, that means the white point should not change during the time you agree that it will survive, several months, etc. So a lot of chemistry inside here. Also stability, jump that, okay.
So a lot of people forget that when you're talking about any form of printing, that the base substrate you're printing on is a color too. And the color of the base substrate does affect certain types of the results when you do a proof or when you print something. So one of the studies that we also have done, and some of the things that we've done to help some of our customers, is not just about making a recyclable media or a more environmentally friendly media. We help them with their programs. So there was a company in the US that had 39 different proofing papers. And so they asked us to look at that proofing paper. They asked us to change a few things around and come up with a rationalized range of stocks for them. And we actually managed to reduce 39 proofing stocks down to 3 using clever design of media and trying to reduce and hit the biggest color gamuts we can, hitting some of the new standards. Because you've got the FOGRA 51 and 52 coming. Well, strangely enough, we'd cracked that one about a year ago and launched some papers, and we also were the first people to put the GRACOL 2013 and get it approved. So I'm going to ask Pierre-Alain to talk in a bit more about how we actually looked at some of those proofing stocks, how we rationalized the range that they had, and how we actually developed a range that reduced the amount of SKUs they were taking, reduced the amount of suppliers they had, and the science that went behind actually trying to find the right color space for the different stocks that we had.
Yeah, okay. So this new FOGRA standard, I don't know if you are familiar with this new standard. It's not coming from the Earth or from the Moon. There have been a need, especially in the States, while the offset paper stock are brighter than in Europe. And here we put some typical paper in America, so sterling. So that's a brochure paper. That's what you use for the offset brochure, etc. And in the States, you have a typical Endurance, Sterling, McCoy, Williamsburg, Somerset, Carolina, and you see in the brightness, L-star and blue scale, they come from -4 to -11. And probably in Europe, there is really stock with more in this region, from 0 here, very neutral, OBA free, etc. And to reproduce that, you better have proofing paper which is bluisher than standard FOGRA 39 paper. Because at the end, the worker will have to qualify on the press if you have the paper which has optical brightener, so you are closer to your target. Okay, but that's bring some pressure to the media designer. The paper are always less stable because OBA is degrading with light, with temperature, etc. So you have to make more research in the new standards. Here. I have 2 things. The yellow things, that's a traditional proofing paper with a Kodak match print, with a GMG Kodak match print type 1, the standard, which is here at 95, -2, and A0, FE, and match print type 3. And with all this paper, if you start with this paper, it would be, when you correct the tint, it would be just impossible to match all this offset paper. So for that, we have developed media, range of media, which starts from here. And if you follow the green line, everything which is below can be corrected with background printing, etc. Background printing, you basically decrease the brightness. So everything here you can correct with a specially tuned proofing paper, and that is what is explained here. With such paper, you can really correct and simulate all this offset paper in America. Okay, and that is a commercial paper we have.
Well, I know we're starting to run out of time, so I'm going to whiz through the last remaining slides. But Sophie, on the proofing side of things, I see the new FOGRA 51 and 52 and GRACOL coming together and making a blue or white point as a major benefit for global printing. I might be wrong, and obviously I've made a paper for it, so I'm going to be slightly biased, but there's been hype about Fogra 51, 52, etc., etc. Have you got any views, any comments?
I think my main view on the proofing side, or with any side where you're going to be talking of any of the standards, is that the standards have been too variable, and a standard should be a standard, shouldn't it? And this is how I view it, but because people have been working to different standards over the years, they've got locked into that mentality, mainly through offset, and the digital algorithm is slightly different, and the standard hasn't been standard anymore, it's wandered. And you've got to start somewhere to get that standard set. And it's not the paper end, it's how you set everything else up to get you to that point where you can apply an algorithm and say that's right or that's wrong. Does that make sense?
Yeah, it does. And I think there's still a lot of confusion in the marketplace. The simplest thing that we really want, as in the print industry, is here's your control document, everyone match it, and everybody able to repeat that control document wherever you are in the world to be able to make your print work on the stock that you're printing on. But that's just my little opinion. That wraps it up. I know it was quite in-depth and some technical bits and pieces in there, but I hope you found some of it interesting. And if you have any questions, and thank you, Sophie, thank you, Pierre-Alain, please ask us.
And I'm sorry I stopped this man from running away.
Yeah, I know, sorry, he was dying to go.
He was doing a runner.